So today, as part of our geometry lessons, we're going to be talking about special segments inside of triangles. We know the parts of the triangle, we know a lot of the vocabulary surrounding a triangle, but you can draw segments or lines that go through or into a triangle, and that's what we're going to talk about today. These different segments and these different points and lines that go through a triangle sometimes have special relationships with each other. So again, as you're looking at your vocabulary for these, when you learn a special segment, you may not want to just know what its definition is, but you want to know what are the special aspects that go along with that segment, and how does that help you solve for something, or set up something, or find something that's missing. So you want to know the attributes of the segment and not just what its definition is. So a couple of vocabulary words here for you. Concurrent lines. Concurrent lines are three or more lines that intersect at one point. If you just have two lines that cross one another, we call that intersecting lines. What happens is when you have more than two lines, they don't always intersect at the same point. And so they're intersecting, they all may intersect with one another, but they're not concurrent. To be concurrent is when you have more than two lines, but they do actually intersect at one exact point. Now, that point where they intersect is called the point of concurrency. And so three or more lines that intersect at one point, and that point where they intersect is called the point of concurrency. Now, we're dealing with triangles. So we do want to talk about the difference between an inscribed circle or a circumscribed circle, an inscribed shape or a circumscribed shape, dealing with triangles for us specifically. But an inscribed circle is a circle that is inside the triangle. Now, it touches the triangle on all three sides. Specifically, it is tangent on all three sides. Now, if you have forgotten what tangent means, a tangent with circles is a line or a segment that intersects that circle in one exact point. So this circle is inside that triangle, but it is only intersecting in one point. So it's not like going out and coming back in. It just rests right on that circle in one point. So tangent in one point, tangent in one point, and tangent in one point. Now, a circumscribed circle goes on the outside. So inscribed, in, that's inside. So the circle is inside the triangle. Circumscribed, circumference, going around. A circumscribed circle goes outside of the triangle. Now, the three places where it touches the triangle is then going to be the three corners. So inscribed circle touches the three sides. Circumscribed circle touches the three corners, or the three vertices. And so that's the difference between an inscribed circle and a circumscribed circle. Just goes around. See, it's been all right. Now, special segments inside of a triangle. Vocabulary words here, okay? Perpendicular, bisector. All of those words are loaded, so you want to make sure you know what that means. Perpendicular means to create a 90-degree angle or a right angle. A bisector, bi means to sect is to cut, so it is cutting it into two equal pieces. Bisectors cut something into two equal pieces. So a perpendicular bisector has to cut something into two equal pieces, and it has to be at a 90-degree angle. So perpendicular bisectors of a triangle go through the midpoint of each side. So each of these sides is being cut in half. Midpoint is that point that cuts it in half, exactly halfway. So it goes through the midpoint. Now again, all vocabulary words are loaded with information. Remember, a midpoint cuts something in half, so that means that we actually end up with two equal pieces. So if this is cut in half, I end up with two equal pieces. If this side is cut in half, then that means that I end up with two equal pieces. And if this side is cut in half, then that means that I end up with two equal pieces. So just saying it goes through the midpoint, don't gloss over that. There's information that's attached to that. So it has to go through the midpoint, and it has to be at a 90-degree angle. So that's what you want to remember. So that means that each side, all right, I've got 90-degree angle, and it cut this side in half. 90-degree angle, and it cut this side in half. 90-degree angle, and it cut this side in half. Now, one thing that you may want to also recognize is that these three lines will always be concurrent, meaning that they intersect at one spot. They intersect in this one spot. Now that point of concurrency, so this is again, you want to associate perpendicular bisectors. Where they intersect, the point of concurrency is called the circumcenter. All right, so the circumcenter is what we call where the perpendicular bisectors intersect. Now, it is called the circumcenter because it is the center of the circumscribed circle. It is equidistant from all three corners. So then you could draw a circle that went around this triangle and was circumscribed. That's why it's the circumcenter. It is the center of the circumscribed circle. That is what that point of concurrency is. Now, angle bisectors. Again, loaded vocabulary words. What do the words give me as far as piece of information? So we already talked about bisect is to cut in half. But this time we're not cutting sides in half. We are cutting angles in half. So an angle bisector has to come from the angle. So that means it's coming through the corner, the vertex. Now, if you go back to our perpendicular bisectors, they didn't necessarily go through the corner. They can, but that doesn't mean that they do. Angle bisectors have to come from the corner. So you have to see hoopies, because if it is an angle bisector, that means that this angle is going to be equal to that angle. You know, this angle is going to be equal to, you know, the other. So they're equal angles. So there's one, cuts that angle in half. There's two, cuts that angle in half. And there's three, cuts that angle in half. Also notice they are concurrent and they intersect at one point. Now, that center is called the incenter. The incenter. So, lots of vocabulary words loaded with information. If you see incenter, you don't necessarily want to memorize just words of a definition. What you want to know is that one word is loaded with tons of information. That is the incenter, which means that these are angle bisectors. If these are angle bisectors, then we know that these angles are equal, these angles are equal, and these angles are equal. That's a lot of information packed into one word. So this is why vocabulary is very important. Also, incenter, just like circumcenter was for the circumscribed circle, the incenter is for the inscribed circle. So this point is also going to give you the distance or the center so that you can draw a circle that is inscribed inside of that triangle, or yeah, inside of that triangle. Altitudes. So another loaded word. This one you may have actually heard before. It is also associated with height. When we do 1/2 base times height to find the area of a triangle, the altitude is the height that we are talking about. So what is required to be an altitude? All right, an altitude is drawn from an angle to the side, and it has to be perpendicular to the other side. So if you remember, perpendicular bisectors were perpendicular to a side, but they didn't necessarily go through the angle. An angle bisector had to go through the angle, had to go to the corner, but it wasn't necessarily anything special to the other side. Altitudes have to go to a corner, and they have to be perpendicular to the other side. So that means that it should touch a corner, and I should see right angle boxes. All right, so again, touches a corner. All right, mine might be a little bit off, but it is actually supposed to touch that corner, to the corner, and to the corner. So it has to go from a corner to a right angle. That's what makes it an altitude, and it is the height of the triangle. Again, notice all these special segments seem to be concurrent. They're hitting at this one special spot, and we call this the orthocenter of the triangle, the orthocenter. So we've had a circumcenter, an incenter, and an orthocenter. And those words are loaded. If you see orthocenter, they're telling you that all of these lines are heights. they are from a corner. It also means that they're 90-degree angles. So even if they aren't marked with a box, if I know that's the orthocenter, then I know that these are 90-degree angles. That's a lot of information just in one word. Medians, another word for another special type of segment. All right, to be a median is drawn from an angle to the midpoint of the opposite side. So, things we got to remember. It does touch a corner, and it's going to a midpoint, which means that our sides have to have two equal parts. So, just like the perpendicular bisector, we end up with the two equal sides. So medians go from a corner to the midpoint. So again, just being told that something is a median, it does actually tell us that we have things that are equal. All three sides go from the corner to the midpoint, from the corner to the midpoint, and yet again, they always intersect at one exact point. Now this point is called the centroid. Lots of vocabulary here, but if I'm told that this point is a centroid, then I know that these two sides are equal, these two pieces are equal, and these two pieces are equal, all just from that word centroid. So again, knowing the definition of a centroid, I'm not really concerned that you can write out a definition. But if you know it's the centroid, you know these are medians. Medians cut the side in half, and that's the information that you want to make sure that you're getting from the vocabulary. All right. Mid-segments. This is a very interesting, we're done with the concurrent ones. We're not talking about concurrent ones anymore, but the mid-segment is a very special triangle segment. A mid-segment of a triangle is a segment connecting two midpoints from two of the sides of the triangle. So this is a midpoint because it cut that side in half, and this is a midpoint because it cut this side in half. And then if I were to connect those two, this would be the mid-segment. Now the mid-segment has some very special properties which are very useful for us. A mid-segment, when you create a mid-segment, you get a lot of information. So one of the pieces of information that we get is that the mid-segment is parallel to the base. Those lines are parallel. Because we know that these lines are parallel, that gives us all kinds of information. It's a mid-segment, so I know that this side is equal to this side, and this side is equal to that side. We know that these are parallel. We also know that the mid-segment is exactly half of the base. Always. If it touches from midpoint to midpoint, then this is exactly half of this. Because this side of the triangle is half of this side of the triangle. This side of the triangle is half of this side of the triangle, which means that this side of the triangle has to be half of this side of the triangle. So it is exactly half of that base. So we know they're parallel, and we know that it is half. Those are important pieces of information. How can we use that to help us solve problems? Definitions. This is a midpoint. How do I know? Two equal parts. This is a midpoint. How do I know? Ticky marks tell me that they're equal. That means that this is a mid-segment. And if that is a mid-segment, then it has to be half of this side. 3 is half of 6, so x must be equal to 6. This always has to be half of that. It really is that simple. Now this one, they tried to confuse me by giving me lots of information. Too much information. So, things that we want to think about. All right, if I look, this piece is equal to this piece. Okay. So these two pieces are equal. This piece is equal to this piece. So that means this is a midpoint, and this is a midpoint, which means that this is a mid-segment. Well, if this is a mid-segment, then I know that it has to be half of this side. So this whole side over here, has to be twice as big as that if it's going to be half of it. So if it's 6, this side must be 12. Now, we know that it's cut in half because these are midpoints. So if it's 12, that means this part is 6 and this part is 6. Now down here, this is a midpoint and this is a midpoint, which means that this is a mid-segment. It means that it's the mid-segment that goes with this one. Well, if this long side is 10, this has to be half of it. So it has to be 5. So when we're looking to answer, find JK, JK ended up being equal to 5, and AB, which was that whole side over there, it ended up being equal to 12. Mid-segments have to be half of the parallel side of the triangle. So try to keep that in mind. They love to draw all of them, okay? You just want to remember that a mid-segment is always half of the side that is parallel to it. So midpoint, those two sides are equal. Midpoint, these two sides are equal. Midpoint, these two sides are equal. So all three of these are mid-segments. Now we are interested in XY. That is this side. In XYZ, which segment is parallel to XY? Well, that would be UT. UT is parallel to it, which means that with these all being mid-segments, if UT is 5, then XY must be 10. Now, because we know these two pieces have to be equal, that means each of them must be equal to 5. So we actually have three sides that are all equal to 5. If we kind of go along the same lines here, this side is 4, this side has to be 8, which means that both of these individually have to be 4. So you can get a lot of information just by being given that those are 5 and 4. Is ST parallel to YZ? So let's see, ST is parallel to YZ because those are equal and these are all mid-segments. This mid-segment is parallel to that side. And then we already found YZ was equal to 8 and XY was equal to 10. Now, what if they give me X's? Woo! Blow my mind. All right, things that we want to remember. I like to label things in the picture. This is equal to this. Midpoint, this is equal to this. Midpoint, which makes this the mid-segment. Now, things that we want to remember. The mid-segment is always equal to half of the base. So in this problem, DE is x plus 2, and BC is 1/2 x plus 19. All right, so if I think about that the mid-segment is always equal to half of the base, then I can say that the mid-segment, x plus 2, is equal to 1/2 of the base, except the base is equal to 1/2 x plus 19. Just because they gave me x's doesn't change the fact that I'm dealing with the mid-segment is half of the base. Now, solving this equation, we just have to remember how to solve equations. If I want to get rid of a fraction, I got to multiply both sides by 2. 2 and 1/2 will cancel out. So I get 1/2 x plus 19 is equal to 2x plus 4. I got to get my x's together, so I'm going to subtract 1/2 x from both sides. So I get 1.5 x plus 4 is equal to 19, and subtract 4 from both sides. So 1.5 x is equal to 15. If I'm going to divide both sides by 1.5, the 1.5s will cancel out, and x is going to be equal to 10. So now I know that x is equal to 10. We talked about this in class on Friday. The question didn't ask me to solve for x. So if I get my answer as 10, I'm going to get it wrong. The question asked me to find DE. So please pay attention to the question. So if DE is x plus 2, and I know that x is 10, then DE must be equal to 12. So do be very careful when you are solving these problems and make sure that you read the question.